Answer the questions about each triangle in the boxes below. Well, while I'm making the video, I'm going to go ahead and work these out, so if you're looking at this after the fact, you'll know where things came from. The first one says find the measure of angle D, and we're going to take 180 degrees, because it's 180 degrees in a triangle, and we're going to subtract 90, and we're going to subtract 41. And when we do all of that, the measure of angle D is going to be 49 degrees. The thing is, if we want to find the sum of angle D and angle O, what we're going to do is we're going to take angle D, which we just found, is 49. We're going to add 41. And when we add those two together, we get 90 degrees. Well, we want to find the sine of angle D, and we don't have any sides on them, or side length, I should say. But if we look at D here, and we label this triangle, we've got the hypotenuse over here. Across from angle D is the opposite, which means that this is the adjacent. So the sine is going to be the opposite, which has a length of GO, and the hypotenuse is the DO. The thing is, when we go ahead to find the cosine of angle O, the hypotenuse isn't going to change, but we have to relabel this graph. And across from angle O, here's the opposite, which must mean that this is the adjacent, and cosine is defined as the adjacent divided by the hypotenuse, so this is GO divided by DO. Same thing happens as we work here on the measure of angle B. When we look at this, we take 180 minus 90 minus our angle of 46, and when we subtract those, we get 44 degrees. If we want to find the sum of angle A and angle B, well, we take 46 plus 44, and what we see is that that adds to be 90. And now, having done the last problem here, we know this length is the hypotenuse. If we look specifically at angle A, across from angle A, here is the opposite, which means that this length is the adjacent. And when we look at this, sine is the opposite divided by the hypotenuse, so it's CB divided by AB. Remember, the hypotenuse isn't going to change, but if we label this triangle with respect to angle B, over here is the opposite, and this is the adjacent. The cosine is adjacent divided by hypotenuse, which is CB divided by AB. Probably getting the hang of things here if you're looking at this after the fact. But finding the measure of angle F, well, 180 minus 90 minus 45 gives us 45 degrees. And then, if we want to find the sum of angle D and angle F, well, 45 plus 45 equals 90 degrees. And when we label our triangle with respect to D, over here is still the hypotenuse across from that box. And then across here is the opposite, which makes this the adjacent. The sine is opposite divided by the hypotenuse. So this is going to be FE divided by FD. And if we relabel here, we don't want to do, oops, the hypotenuse isn't going to change, by the way. Still the hypotenuse here, but if we label with respect to angle F, here's our opposite and here's the adjacent. And our cosine of angle F is FE, the adjacent side, divided by the hypotenuse, which is FD. So what did you notice about the sum of the acute angles in the right triangles above? So if we go back to our chart here, and we look at the sum, it says find the sum of angle D and angle O. Find the sum of angle A and angle B. Find the sum of angle D and angle F. What you probably notice is that all three of them added to be 90. And when we have two angles that add to be 90 degrees, they're called complementary. What did you notice about sine of D and cosine of O in the first triangle? Well, we ended up with GO over DO. GO over DO. They ended up to be the same. If we go back to our chart, which you can see on your paper, I just can't see on mine, it says, what did you notice about sine of D and cosine of F? Well, once again, I think what I might have meant to say is sine of A and sine of B, but here's sine of D and cosine of F. I just read it wrong. What did we notice about sine of A and cosine of B in the second triangle? They are the same. And somebody said equal. And if we look at the third triangle, what we still see for angle D and the sine of D and the cosine of F, we ended up with FE divided by DF in both of those situations. They are the same. So can we make a conclusion about the sine and cosine of complementary angles in a right triangle? In fact, even more specific, acute angles in our right triangle? Well, what we can say is that they have the same ratio. They are the same. I'm going to go back and look one more time once you get it written down. If we go back here again, what we ended up with GO divided by DO, written in blue, written in green in that first box, or CB divided by AB for both sine of A and cosine of B. For sine of D, FE divided by DF, cosine of F, FE divided by DF. The ratio, it's the fraction that we filled in. For sine, opposite divided by hypotenuse, cosine, adjacent divided by hypotenuse. In other words, there is a theorem called the complement theorem, which says if angle A and angle B are the acute angles of a right triangle, then every single time sine of angle A will equal cosine of angle B. And if you know that, then these problems are not very challenging. So it says right triangle FGH is shown below. A sine of angle F is 0.53. What is the cosine of angle H? Well, if we apply the complement theorem, then what happens is that the sine of angle F is going to equal the cosine of angle H. And because the sine of angle F is 0.53, that means that the cosine of angle H is 0.53, which is the answer that we want to have here. But what if you can't remember that when we get put in a testing situation? Well, what we could do is we could rewrite sine of angle F. And we could rewrite it, instead of a decimal, we could write it as a fraction. 0.53 is the same thing as 53 divided by 100. So we're looking at angle F here, and as we label, across from the right angle is the hypotenuse. Across from angle F is the opposite, which means that our remaining side is the adjacent. And when we fill that in, opposite divided by hypotenuse. Now we know those lengths, and the question is, what is the cosine of angle H? Well, we need to relabel with respect to H, so that opposite's going to go away. But the 53 and the 100, they're not going to go away. The hypotenuse isn't going to change. But now, if we label with respect to H, across from H is the opposite, which means that the 53 is the adjacent. And notice what we get for cosine. Cosine of angle H is the adjacent divided by the hypotenuse. In other words, 53 divided by 100 is 0.53. Very long way to talk about the complement theorem. Again, two acute angles of a right triangle, the sine of one angle is equivalent to the cosine of the other. And we won't take so long on this one. It says in the right triangle below, the cosine of angle U is 3/4. And what is the sine of angle W? Well, cosine of U equals 3. Cosine of U should equal the sine of W. So the cosine of U is 3/4, which means that the sine of W should also be 3/4. There's what we want to answer. Example 3. In order for sine of A to be equal to cosine of B, in order for those to be true, angle A and angle B have to add up to 90 degrees. We don't need a degree symbol. It has to add up to be 90 degrees. So one of the questions that we could ask is write an equation. And we kind of did that on the front in our boxes. But what we can say is we could say that the measure of angle A plus the measure of angle B is 90. And if we want to write the equation in terms of angle A, I'm going to take out the measure and the angle, and I'm going to simplify that a little bit. I'm going to start with angle A plus angle B equals 90. But we want to rewrite this so that we have A equals. How to rewrite this in terms of angle A? Well, subtract angle B from both sides. We end up with A equals 90 minus B. We subtract from 90. Same idea over here on part B. What if we want to write the equation in terms of angle B? Well, we can still start with A plus B equals 90. I just took out the measure and the angle symbol. And we're going to solve for B this time. So we're going to subtract A from both sides. And we end up with angle B equals 90 minus A. Complementary. Two angles that add to be 90. Once we have this in our minds, then we can find the value of x that makes each statement true. Well, it says sine of x equals cosine of 25. So this is using the complement theorem. But what happens is that angles A and angle B are complements. In this case, angle x and angle 25 are complements. So if we want to figure out what x equals on this particular problem, what we do is we take x and we take 90 minus 25. 10 minus 5 is 5, and 8 minus 2 is 6. And our x is 65. Complementary. They add to be 90. It's the same idea on letter B. Letter B. We've got sine of 80 equals cosine of x. We want to figure out what x is. The complementary theorem says that x is going to be 90 minus 80. So x is going to be 10 degrees. And you're probably getting the hang of it when we get to this third one here, letter C. Cosine of x equals sine of 75. The cosine of one acute angle in a right angle is complementary to the other acute angle. In other words, x equals 90 minus 75, if I can write it. So x, in this case, is 15 degrees. Finally, a potential OST question, which doesn't look like it's very tough, but again, think of it from the perspective of, you know it now in the unit, are you going to know it when it's mixed up with everything else? And as we look at this one, it says angle A is the complement of angle B. It says which equation about the two angles must be true? Well, first of all, as I look at the answer, sine of A equals cosine of A. Can't have the same angle. It's not going to be that one. Same thing here. Cosine of B, sine of B. Can't have the same angles. So now we're down to 2. Cosine of A equals cosine of B. So we've got the same trig function. Or in D, cosine of A equals sine of B. And if we go back to the very top of our paper, what it says is sine of A equals cosine of B, or vice versa. It means that we have to have letter D. We have to have the cosine of one angle equal to the sine of the other.